right, hello everyone. Boker Tov, good morning. I'm so excited to be here back in Tel Aviv. Thank you for having me. Thank you to the NodeTLV and EventHandler folks and all the organizers. This has been a wonderful time. Wow. Also, this green lighting is really cool. This is a great venue. I'm here to talk to you today about tooling. I'm an open source developer. My name's Josh. I work on projects like ESLint and TypeScript ESLint that I hope some of you use to spot bugs and help format and enforce stylistic consistency in your code. I'm also the author of the Learning TypeScript book published through O'Reilly and a co-organizer and co-founder of SquiggleConf, a conference for excellent web dev tooling in Boston. I love dev tooling. I love great web dev tooling. I love things that make me better. Because better dev tooling makes me a better developer. Dev tooling will catch bugs for me because I cause a lot of bugs. I don't know about you. It helps me write code faster. It helps me write code cleaner with more stylistic consistency. It educates me on best practices. These are all things that we're going to learn about today. Now, dev tooling, or tooling in general, is a big area. Once we have this developer idea of writing code, we put it in an editor, and then we build it, and then we run it. And by developer, I of course mean developer with some AI agent that they're maybe supervising. But for the sake of this talk, and because we only have half an hour, I'd like to focus on just the editor part of this. And for the most part, I'm going to talk to you about tools that cause the little squigglies. So whenever you hear me talk about squigglies, it's the little underline, like the spell checker in your editor. And specifically, I'm going to, within that, talk about 4 general topics or areas of dev tooling, and we're going to end with some nice ways to get started on your own. Because there's a lot of tooling out there. The JavaScript web ecosystem has a lot going on, and there's a lot of cool stuff you might want to configure. So with all that being said, are we ready to get started? Woo! All right. I've had so much coffee and so little sleep. This is going to go well for everyone. Let's talk about the formatters. This is the first of the 4 sections. Formatting is the concern of show me the code. Show of hands. Who here prefers the stuff on the left, the code snippet? Who here prefers the snippet on the right? Not everyone raised their hand, but thank you to the majority who did. The duality, the horror of writing code, is that consistently formatted code is easier to read. Thank you for correctly raising your hand on the one I wanted you to. But consistently formatted code is harder and slower to write. You have to press tab or space or whatever your juice is. You have to do the new lines. It's a lot of work. Fortunately, we have tools that do work for us, that can quickly look at our code, scrutinize it without running it, and then maybe rewrite it or suggest fixes. We call that static analysis. Static analysis tools, such as formatters, exist on a spectrum, from the very fast, speedy ones to the slower, more powerful ones. We're going to talk about this whole spectrum and more, and we're going to start with formatters. Yes. Prettier is kind of the most common, popular JavaScript web formatter. Just show of hands, who here uses Prettier already? Awesome. Who uses Biome, or OX format? A few people. Hi, Ronan. So you run Prettier -- write, and it'll rewrite your file for you. That's great. Prettier is super fast. It is convenient. You don't have to configure it. It's a lovely tool. It and other formatters like it, Biome, OX format, and so on. You can format Prettier if you want, or configure it. We'll look at that later. But at the very least, I recommend finding the general getting started settings for your editor with Prettier. In VS Code, I like the new Prettier VS Code extension. And I also like setting Prettier as my default formatter, alongside configuring VS Code to format on save. That way, whenever I save a file, it gets auto-formatted for me. And if I save a file and nothing happens, my ugly code snippets don't fix themselves, then I know I have a syntax error. It's like a nice little emotional response. But you can configure Prettier. You can, for example, say use tabs true in your Prettier RC, your config file. I'm told that this is better for accessibility, so I generally sometimes do this. And running Prettier again, we'll switch to tabs. My slides just froze. That's not good. Oh, there we go. All right. Another thing you can do is load in plugins. Prettier actually does have a plugin system. I personally really like this plugin I published called Prettier Plugin Curly, which enforces that you have the little curly boys after your ifs and whiles and such. So you run Prettier right, and it'll add those in for you. Easy peasy. Not much to cover here. So I'm going to move on to something a little more powerful, the type checker. Type checkers answer the question of, can I do this? Is the code that I'm writing probably going to not crash, or at least work the way that should be done? And of course, the most powerful, popular type checker for JavaScript is TypeScript. Yay! Big fan of that over here. Someone said TSGO. We'll talk about that, yeah. TypeScript, because I know not everyone here uses it or writes it, is JavaScript plus types. There's a JavaScript syntax, all that lovely stuff you have a love-hate relationship with, plus some added extra stuff, these little type annotations and other things. Then there's also the tool, the TypeScript command line, or TSC, that looks at your code, your TypeScript and JavaScript code, and lets you know if there's any mismatch between your values and the way you use them, the intent and usage. And also there are integrations, such as in VS Code, where you can get the little squigglies in the editor. Love those squigglies. Now, when I've worked with teams to onboard and utilize TypeScript, I've found there are generally kind of three main areas of work or challenges that one faces with TypeScript. Adopting it, getting it to be powerful enough to represent the wild and wacky stuff you do, and then speed. Once it's powerful, can it also run quickly? And within adoption, there are kind of two sub-challenges. There's JS to TS, starting with your existing JavaScript code base and migrating it to TypeScript. And then there's TS to JS. You have your TypeScript code. How do you build it into some sort of JavaScript thing that can be run? Let's go through those in order. JS to TS. TypeScript doesn't force you to be all in. It's what's called a gradually typed language, which means you can configure it on a kind of sliding scale from what we call weakly typed, which is still more typed than JavaScript, all the way to strongly typed with the most strict settings. Obviously, I personally prefer strongly typed, but there are trade-offs here. It's a little harder to write, a little slower. And by default, TypeScript starts off weakly typed. Here we have a food parameter to our plead function, which is type, heck if I know. This is the implicit any. It is implicitly, meaning we didn't say anything, it just is, the any type. The I don't know what this is, YOLO, you only live once, let me do anything. And by default in TypeScript, that's just fine. You can do that, which is not very safe. So there is a compiler option for TypeScript called noImplicitAny, which you can enable to make it give you a type error on any sort of implicit any, such as on a parameter. That's good. Oh man, this clicker. Now, you can generally resolve that by adding something like a type annotation. It's up to you in your code. But moving on, you don't have to adopt TypeScript all at once. You can incrementally migrate some files to TypeScript and keep others on JavaScript. But by default, TypeScript won't read and file types, or types in general, from those JavaScript files. So actually, they also form another kind of any in your code base by default. But there is a compiler option, allow.js, that allows you to read in JavaScript files. Good stuff. Now, one more thing that I'd like to show you about the default TypeScript options is null safety. By default, if you pass null in a place that expects a more defined type in TypeScript, and also a lot of older languages like C++, older versions of Java and C#, that's just fine, which is weird to me and to many people. That's not great. So there is a strict null checks option that you can enable that says, no, null is not just allowed to be anywhere. It's its own type. And you get a nice type error if you try to use it. So we've covered multiple options here. We've already covered 2 strictness options. And there are actually quite a few strict options in TypeScript. I generally recommend use the catch-all umbrella strict true to enable all the strongly typed stricter options at once. If there are any you disagree with or don't have time yet to onboard, you can always disable them one at a time. So just in general, strict true is kind of the canonical, best way, if possible, to use TypeScript. But okay, that's adoption. Let's talk about the other way. TypeScript files, need to build it and run it somehow. Because you can't just run TypeScript. TypeScript is not the JavaScript language. V8 and other runtimes don't run TypeScript code, they run JavaScript. All that extra garbage that you added in your TypeScript file, the interface, the type annotation, that's not JavaScript, and it'll cause a syntax error if you try to run it. Well, there are a few ways you can deal with this. One is you can run TSC in watch mode, or in general. TSC doesn't just type check, it can also emit JavaScript files and other outputs. which means in one terminal you have TSC, and in the other you can run Node on the built.js, which is kind of a pain in the butt. So now we have tools also like TS Node, which will do that behind the scenes for you. They kind of take the place of Node, but let you run TypeScript directly. And Node also has its own sort of loaders format, so you can do this extra thingy, which is more Node native and probably theoretically better, and the people here working on Node are probably happy that this is known. But it's still kind of a lot of stuff to write, and it's a third-party dependency for TS Node. Now, other runtimes, other than Node, have for a little bit now supported TypeScript natively, most notably Bun and Dino, which is great and convenient. It just works out of the box. And I'm very happy to say that I think as of last week, the latest LTS versions of Node support running TypeScript directly, which means you no longer need a third-party dependency to run TypeScript. Yes! Thank you, Node people. So excited. And another thing that should get a lot of people here excited and isn't controversial at all, let's talk about AI a little bit. So it's 2025. We're going to slap it on there because I'm told this is good. TypeScript is actually useful for more than just your TypeScript files. It's really nice for AI prompts too. For example, let's say that you want to get some JSON or plain old JavaScript object description of places to go in Tel Aviv. You could manually type out, give me an array of this with that thing, and if this is that. Or you just provide a TypeScript type. You can provide those types as plain text and feed them to the AI, and all these LLMs are smart enough to use that as the type. That's stage 1 of 2 for using TypeScript for your agents and AIs. Stage 2 would be to have some sort of validation that if their response doesn't match the format, it would be cool to tell it and then maybe auto-fix it. And I would welcome you to try out this really cool research project from Microsoft called TypeChat that actually roughly does that. If you have some nice response from the AI that doesn't quite match the types, it'll detect that by using the type checker and then do the equivalent of kind of reprompting the AI with the type errors so that you can get a corrected response. Now, I've given a lot of demos using the free tiers of AI SDKs and AIs, and I got to tell you, the not getting the data in the right format is a real pain in the butt. This type of thing is really nice. But okay, that's adoption. Many of the ways you might use TypeScript anew. Let's talk about power. Is TypeScript a powerful type system? The answer is freaking yes. And I'm not going to dive into the features, but I will tell you, as just one example, that my SquiggleConf co-founder, Dimitri, got doomed to run in the TypeScript type system, not at runtime, purely in the language's types. He got a full WebAssembly runtime working. It's hard to see maybe from the back, but this is his face when he got a template literal type, a string type, representing the first frame of Doom to render. He's so cute. Look at him. TypeScript's pretty powerful. But what is the downside of that power? Speed. TypeScript is fine for small code bases, but at scale, oh my God. So they are rewriting TypeScript in Go. Pardon me, they're porting TypeScript to Go. And actually, Daniel Rosenwasser gave a great talk at React Next yesterday on this. But skipping over the details, it is absurd. It is 10 times faster. It is really cool. I highly encourage you to go read the blog post announcing it. I also would highly encourage you to try out the native previews. The team is actively looking for people to try it out. So if you've got a big code base, TypeScript's a little slow, try it out. Even if you don't, it's kind of cool to try the new version of TypeScript. It's got a really nice editor integration. Would recommend. Okay, I've talked a lot about TypeScript. Speed is coming. I'd like to move on to some other things now, because I actually work on linters day to day. Who here works on any sort of linter? Woo! Yeah, all right. Let's talk about linting. Type checkers answered the question, can I do this? Linters answer the question, should I do this? That classic Jurassic Park quote. And linting with ESLint is kind of the standard way most people for a while now have been linting in JavaScript. There are other linters, I'll mention them later. You run ESLint on the command line, and it gives you, let's say, a complaint from a rule. Unlike type checkers, linters must be configured generally, or at the very least they provide a large set of rules. Each rule checks for one thing and can be configured individually. Here we see an error or a report from the no unused variables, or vars rule. Much like Prettier and TypeScript, they have editor integrations. I'm going to surface lint squigglies as this nice yellow-orange here. In VS Code, as with other editors, there's a nice extension you can use and some settings you can set. I recommend installing them. It makes for nice squigglies. I also recommend enabling the source.fixall.ESLint code action in VS Code, because a lot of lint rules provide safe auto-fixers, kind of like little mini code mods, which means not only can you auto-format your code and save, you can also clean it up in ways that are safe, which I find very pleasant. And if you set up ESLint using the recommended settings as shown, you get more red squigglies, which is kind of inconvenient because these are the same red squigglies that you get from TypeScript. And it's not actually possible to determine just from this visual what's the TypeScript squiggly versus the ESLint squiggly. And if you're in the middle of a refactor and you've got a lot of ESLint or TypeScript ESLint rules enabled, you're going to have a lot of squigglies. So I recommend adding this little setting. I'm very proud of this. I actually added this setting to the VS Code extension with a few other folks called ESLint.rules.customizations. For example, you can downgrade all rules, just their visual report, not their actual command line setting, which means that your squigglies become a nicer, little more gentle yellow for ESLint. Hell yeah. Woo! It's amazing to me what's exciting to people. Like this makes me so much happier than the years of decades of research programming languages stuff. But let's talk about linting, because linters have a lot of different uses. They're not like formatters that are just for the one thing. Another good example of something you can do with linting is enforcing or teaching new syntax. Who here has written x equals x or y, or something like this before? I would assume most of the room is either shy or raising their hand. Yes. Fun fact, there's actually a newer operator, an or equals, that you can use, and there's a core ESLint rule that enforces using that. You don't have to use these stylistic rules. I just find that their auto-fixers make for cleaner code. Like, who here has written this before? This little pipey friend. This is good stuff. But all this is syntax. I've just shown you lint rules that are based on syntax. And one file at a time syntax is nice, but we've also previously seen TypeScript with type checking. And that's more powerful. But if we could combine type checking, take the information from TypeScript and use it to inform our lint rules, we would get this awesome sort of super powerful in between the two 1.5 linters, which is what projects like TypeScript ESLint that we work on do, and also a lot of newer linters. And I'm very excited to show you some examples of why that's useful. For example, this very applicable, approachable, I'm sure many of us have written await console.log before, right? I guess not. This is an example. But the idea it shows, I think, is really interesting. We use the type checker to determine the function call's return type, in this case, console.log's return type, to be void, nothing, ignored it, which means that the await is unnecessary. And the TypeScript ESLint, that's the TypeScript plugin for ESLint, rule await thenable says, hey, you awaited something that's not a thenable, something with a .then, most commonly a promise. And that can be suggested to be removed. But I'll show you an example in a moment that's actually a little more real world. And I will note that one of the other many benefits of linters is that they can work on code that you yourself may not fully understand. They're great for when you're onboarding to teach you about the new wacky code that you have to introduce yourself to. And I realize this is a room full of maybe just Node.js developers. So let's look at some React front-end syntax. Does anyone see the violation of await thenable here? I'll give you a hint. It's the only await. That's right. It's right there. And there are actually, in this snippet, a couple of ways we could deal with it. We could see that, okay, the onClick is a function that returns void. Well, we could change that onClick to allow async functions to have them be returning promise void. That's one way to fix this. Or, if we know that, no, the await is actually unnecessary, the onClicks are only ever synchronous, we could, remove the await, which then means that the React state set running and then immediately another set running are unnecessary. They cancel each other out, which means we get another lint rule saying that this function is unnecessarily async, so we can remove that, which means the function is just a query to one function, so we can get rid of it, which means that the set running variable is now unused, which means that running, which is only ever false, can just be inlined to be false, which means button disabled equals false can just be removed because that's a default. Also, I don't think disabled equals false is accessible, I'm not sure, or disabled equals true, which means we just got rid of a third of our code with linting. Yay! The power of type linting. Yes. All right. Now you're all convinced. You're like, yes, Josh, I used to hate ESLint. Now I love ESLint. Let's lint some more. Let's throw in some more plugins on there. Let me show you the world. ESLint plugin deprecation adds a rule that lets you know if you use something that's marked with the community JS doc at deprecated. This plugin is deprecated, and we actually built the rule into TypeScript ESLint. I love it so much. Thank you to the previous plugin authors. ESLint plugin, ESLint comments. You can disable lint rules in line. It's actually very handy, and that's the recommended approach for when a lint rule is actually wrong, which does happen sometimes. But you might forget to re-enable them for the rest of the file, or you might forget to include a reason why. So this comments or plugin helps you keep good practices there. Then there's ESLint plugin JSDoc rules around JSDoc comments, including one of the favorite plugin rules I've ever written called informative docs that lets you know if the doc comment for something just restates the thing's name. Why? Then there's ESLint plugin JSX-A11Y, or accessibility, letting the front-end folks know, hey, you, for example, have an image that doesn't have alt text. That makes it inaccessible. Visually impaired folks, screen readers, and other assistive text, search crawlers, they don't know what that is. Then we have ESLint plugin N for the backend areas, a lot of good Node.js best practices. Maybe you import from a package that's not referenced in your package JSON, and this might deploy and fail in production. This plugin, I don't know how you all are going to handle or receive it. One of my favorites, Perfectionist. It sorts everything. And I mean it can sort everything, objects, properties, imports. I personally like sorting everything alphabetically. Love me an O of log n search. Other people hate this and tell me they don't want to contribute to repos with it enabled. You get to choose. But something that everyone should have enabled is the regular expression plugin, which detects, among other things, polynomial backtracking in regular expressions, which is, I think, one of the top reasons for the CVEs that constantly get spammed around on GitHub. There's a lot of powerful stuff in the ESLint plugin ecosystem. And what's the downside of all that power? Speed! Who here's sworn at ESLint for being slow before? Yeah, okay. What if we just rewrote it in Rust? Is kind of the meme from the last few years. TypeScript's getting ported to Go, so maybe it's just rewrite in native speed. There are quite a few awesome, really exciting projects that are looking at how do we rewrite the linter or reimagine the linter in a native speed language. Biome was one of the early ones. Dino has its own linter. The OXC project has a linter. Fun fact, Biome and OXC also have formatters, which are very pretty or compatible and very fast. And they do more than just, it's the same but Rust. They actually kind of apply something around a decade of community learnings from ESLint. ESLint has a lean core. You have to use plugins for a lot of areas of functionality, which is great for letting the community iterate, but not so great if you just want to get started. Biome, OXC, and so on, they build in a lot of the kind of common community plugins and rules. ESLint doesn't support TypeScript natively. You have to have TypeScript ESLint. These ones also support TypeScript out of the box. And they use native speed types rather than the current JavaScript speed TypeScript. I think that's great. I'm really excited about this iteration. However, I do have one gripe, which is that as a TypeScript developer, I don't really want to write Rust. I also think it's kind of a large tax on teams if you want to write custom lint rules to force the team members to learn a new language. So I'm actually writing my own linter. It's called Flint. I'm sure this is going to go well for my mental health over the next year. It is a fast-friendly linter. It's not ready. This is not a plug. Please don't use it. It is nowhere near production grade. It's mostly the same conceptually as these new ones, but it's written in TypeScript, and it uses different strategies to try to achieve that same really nice performance boost. More around caching than concurrency. But it does use TypeScript Go. Now, obviously, I think I'm correct and everyone else is wrong, but I'm probably wrong about that. So do your own research on linting. It's a very exciting time to lint. But I got like 5 minutes left, so let's move on. Pruning, a couple of miscellaneous tools here. We've answered the questions of, show me the code, how do I look at it? We've answered, can I do this, and should I do this? Now, we've done it all correctly. Did I even need to do this in the first place? Do I have big unused areas of code? And the king of all tools for this is knip. Comes from the Dutch word for snip. Knip is a command line tool that will read in your files, all of them, and let you know if something exports a construct or declares a dependency that isn't needed. If we were to run knip on this, we would get a notice about fruits, specifically the banana fruits. Because if this is the only 2 files in the code base, then yeah, banana is unused. And I have consistently, every single time I've run knip on a new project, found a shocking number of unused things, which is bad. It slows down code, it slows down builds, means that you take longer to read the code base. Also, knip can look at your package.json dependencies. Here, if this is our only 2 files, we would get a complaint from knip on ddent, because nothing uses it. Chalk is used, ddent isn't. And again, that's not great. Unused dependencies unnecessarily bloat your node modules, make installs take longer. Who wants that? We don't want that ddent. Now, another form of deduplication is pruning your transitive dependencies. Here is an incorrect representation of these 2 packages, chalk and ddent. Let's say that chalk takes depths on A and B, ddent is just B. You can visualize that in your node modules with this kind of tree structure. And depending on what order and what time you install your packages, you might actually get duplicate versions of packages, in this case, example B, even though they could resolve to the same thing. You'll notice that they have different versions, even though the chalk dependency on example B is a higher patch than example B's. Their resolved ones are the opposite somehow. So if you were to run the dedupe command from your package manager, npm, pnpm, yarn, and so on, they can sort of automatically hand massage your lock file to deduplicate. Pretty useful stuff. Now, I've shown you a lot of tools, and I know that's a lot of information. I think they're all great and cool. But the last thing I want to end with in my last 3.5 minutes is the templates. You've got all this awesome stuff. You're so excited about ESLints. How do you set it up? And I want to answer that question with templates, because there are enough tools out there that I don't want to have to constantly copy and paste and relearn every time I new up a project. I want to just have it done for me. And back in the day in the front end, we used Create React App, which is now deprecated, shout out front end. So now there's Create Vite, and we also have specific versions for different frameworks like Next App and Remix, and I maintain Create TypeScript App, which is kind of a general Node TypeScript version. But most companies I've talked to eventually end up making some template for themselves, a lot of open source developers too. And it's pretty straightforward to write a good template. I'd recommend trying it out just to learn the tools, see what you like, what's common across all your projects if you have multiple. The problem, though, is that great templates are actually infuriatingly difficult to write. It is so annoyingly hard to write a good template. You'd think it would be easy. You'd think it's just some config files, but there's so much that goes into them. Let me show you. Let's say you just want to do those forms of static analysis, formatting, linting, type checking. Well, now if you want a good reusable template, you might need to expose the default version and then also the -- TypeScript flag, which means that TypeScript now has to influence whether the lint config, if it's ESLint, includes TypeScript. And then God forbid you include the tester, which also has configuration files. And you're outputting multiple files. The package.json file takes inputs from all your settings. Plus, it's not just config files. You might make a YAML file for your CI actions. And then what if you want to send network requests for your GitHub repo settings? You end up looking like Charlie from It's Always Sunny because you have these interconnected dependencies. It's a whole thing. So, a few thoughts here. I make a framework called Bingo, which is a really, I think, nice way to set up these interconnected block dependencies. I use Bingo to make Create TypeScript App, which will set a lot of this up for you. And I've got about a minute, so I'm sure I can give you a full demo that shows using Create TypeScript App there. Let's do Create TypeScript App offline. That should work just fine, please, for the love of God. I'm going to make it in my TypeScript app directory. I'm going to do the common preset just to not overload us. I will note I just introduced a performance regression last week, so that's great. All right, let's do my TypeScript app. Is it working? Hell yeah. All right, so this set up my files. It's like a very basic thing. Since I didn't show testing in the presentation, I'll show that this sets up tests for you. I added a really nice utility that I made called console fail test that fails tests if you call to the console. Very useful if you're trying to clean up. But let's switch greet to async, and we immediately get a lint complaint that it has no await expression. And if we run pnpm lint on the command line, we get actually a bunch of complaints. Shout out to my favorite lint rule of all time. Who here runs no floating promises, the lint rule? Wow. Oh, not as many hands as I thought. Oh, well. Anyway, that's just a quick example. I don't have time to dive into it. But it is fun to be able to show in the demo that you can just get a new repo in like 5-10 seconds. All right, so the conclusion there is automate the annoying parts. Learn the types of tooling and things that you want or don't want and make a template for it. Or just use Create TypeScript app. I'm over time, so I'm just going to close with a few thoughts. For starters, if you wanted to take a photo of something that has resources, this is the slide to do that. I'll wait until I see hands no longer going up. There are a bunch of awesome staples, mainstays, prettier, TypeScript, ESLint, and some new fun ones like Create and Biome. I'm very excited about them. I hope you are too. I think it can be very painful to exist in an ecosystem that's constantly iterating and learning and doing whatnot. But the result is that we have a lot of really nice tools. So I highly recommend try to keep up to date. Don't let your dev tools behind. Set up your tooling like it's 2025. Thank you.